Okay, hello everybody. Welcome to this webinar, Tilting the Working Plane with a Spatial Angle. My name is Michael Wiendl. I'm an NC trainer at the training department here in Schwanreuth, and I want to show you in the next hour the function to tilt the working plane with one spatial angle. If you have any questions, please use the question window, and afterwards, after the presentation, I will answer the question which you have here. Okay, so let's start. At first we start with the fundamentals for tilting. So everybody knows from the basic training we have our three linear axes, the x-axis, the y-axis, and the z-axis. So for tilting we need three more axes, our round axis. And these round axes or rotary axes are A, B, and C. So A is the rotary axis around the x-axis, B is the rotary axis around the y-axis, and Z is the rotary axis around the z-axis. So, also very, very important, like in the basic training also, we are always programming the tool. We are not programming the movement of the workpiece, we are only programming the tool. So we are not looking at our machine if there is a table, if the table is moving the workpiece or the head is moving the tool. We are only programming the tool. That's very important, especially for the customers who have a table machine, because they often want to move the workpiece, but this is not the correct way. You always program that you program the tool, and the workpiece will not do any movement. So, in our machine we have two different types of angles. At first there are the axis angles. The axis angles are the physical axis of the machine. So it depends on the machine which angles you, which axis angle are available. For example, for our example here, we have B head and C table. There are different other combinations what you can have, but what you see in the status display is the axis angle. Also, you can move this rotary axis with the manual operation with the keys plus or minus, and then you move the rotary axis to an axis angle. So now we want to have an example. We want to move the axis, the B axis of our machine to 30 degrees. So our B axis is a head axis, so the rotary axis is in the head. So I program B plus 30, linear B plus 30. So the head is moving to the right side, and in the display we can see, okay, this is B plus 30. You see? The axis went to the right direction. The same example with a machine with the B axis in the table. You see the same value in the display, but the table did the movement in the left direction. And that's because when we program an head axis, so we want to program the example here, there we use the right-hand rule. So the right-hand rule says we use our right hand, we just grab the y-axis of the machine, that the thumb will show into the positive direction, and then we just change a little bit our fingers, that we get a little circle in the hand, and then we get the correct value to the positive direction of the rotary axis. We will see it later with the right-hand rule for spatial angles. And the same if you have a table axis, there it's the left-hand rule. So with the left hand, you take the positive linear y plus direction with thumb. The thumb shows in the positive y direction, and the fingers will show you the positive rotary direction of the b-axis. And because of this, we have a different behavior if the b-axis is in the head or the b-axis is in the table. The result on the workpiece is the same. So we get a chamfer of, or a surface of 30 degrees. The same for A and C axis in the table. There we also need to program then the A axis. So this is also important. I only can program, when I program with axis angles, I can only program the physical available axis. So when I have a machine with A and C, I cannot program a linear B minus 30. Then I get a fault that I programmed an axis which is not available. So once again, axis angles are always depending to the type of the machine. So you need to program your program for a machine. For example, you have a machine with a B head and a C table. Then you need to program this program exactly for this machine. But when you want to change or to take this program to a machine with A axis in the table and C axis in the table, then you need to change the complete program. And this is the disadvantage of the axis angles. Also important, you need to know if the rotary axis is in the head or in the table because of the positive direction. Is it left or right side? So is there the left-hand rule or the right-hand rule? So it's really not a good way to program the machine with axis angles. It's better if you have two round axes, two rotary axes, that you use the spatial angles. So spatial angle, there we have a function, so-called plane spatial. And with this plane spatial, we can program spatial angles. And therefore, we also have our coordinate system. If you take part in a training, then you always get the coordinate system from HEIDENHAIN. And there you also have the rotary axis on it. And with this coordinate system, you can easily check which is the positive direction of the rotary axis. So for spatial angle, when we want to program spatial angle, we need to program the plane spatial function. So plane spatial says I enter a spatial angle. So the working plane will just rotate with the programmed values from my spatial angle. Also important, my z-axis is always perpendicular to the tilted surface. So after tilting, z is always perpendicular to the surface. Programming is easy. I just use my right-hand rule. You see it on the picture. You just take the axis, the x-axis for example, with your hand, and the thumb shows in the positive direction of the x-axis, and then the fingers The other 4 fingers show you the positive direction of the rotary axis for the spatial angles. So you see it when you compare it with the picture above, you see a plus, the same direction of the fingers. And this example you can use also with the B and the C rotary axis. So now it's important for us for spatial angle, for programming with spatial angles, we only need the right-hand rule. So this is for us the important way, just to get the information in which direction is plus or minus. We want to do an example. As you can see here, I want to mill a surface with an angle of 20 degrees. So, and you also see the coordinate system. The angle is not A plus 20. The angle goes backside, so the surface goes backside, though the angle is minus 20. The surface should look like this. At first we make a datum shift to the beginning of the surface, and the next step we tilt our coordinate system on the surface, and then we can start on working on the tilted surface. Programming this value, we can use the NC sentence plane spatial, SPA minus 20. We will talk about the definition later. You see here, my spatial angle is A minus 20. But my machine does not have an A axis. My machine has a B hat and a C table. But the control knows, okay, I have a B hat and a C table. So with a combination of these 2 rotary axes, I can also move the workpiece to the correct position, that on the workpiece I have the SPA minus 20. And you see the green one is the spatial angle, SPA minus 20, and the red one is the axis angle. So the control needs to move the C axis to 90 degrees, and then the control moves the B axis to plus 20, and the result is an A minus 20 angle on my workpiece. So this is the difference between spatial angle and axis angle. Spatial angle is always an angle defined on the workpiece, not looking at the machine, and the machine needs to look in the kinematic description what rotary axes are available, and then the control can position this rotary axis, and this you see in the status. Here you have the value of the B and the C axis, for example. The same sentence also possible on a machine with a B and C table. The same value, the same program, but here you see different behavior on the machine. But on the workpiece, the same surface. The same value on a machine with A and C axis. Also here you see the spatial angle and the axis angle. So for machines with kinematics which are perpendicular, so 90 degrees kinematics, the angles are often, or the axis angle are often really easy to understand. If the kinematic is not 90 degrees, then it's a little bit, the programming with axis angle is nearly impossible. Because if you see here, I have defined a spatial angle of A minus 20, and this is the axis angle for my machine here with an double tilting table with an angled kinematic. So the green one is the programmed angle, SPA minus 20, and the red area shows the axis angle for this spatial angle. But on my workpiece I have once again the correct spatial angle of minus 20 degrees in the A-axis. So for us, the easiest way to program a tilted working plane is the plane spatial function, because then we do not need to look at our machine. We only can program our program just looking at the workpiece and the tool. The definition of the plane spatial functions, we go to Program and Editing, Special Functions, Soft key, Tilt, Machining Plane, and then we have the first soft key, plane spatial functions. Then we can define all the three spatial angles, and the next step we can say the movement of the rotary axis should be with turn, and then Fmax for the feed rate. So what do I need to input for the plane spatial? I need to input the three spatial angles, SPA, SPB, and SPC. I always need to program SPA, SPB, and SPC, also when they are 0. So for our example, plane spatial, SPA minus 20, SPB 0, SPC 0. So there's no possibility to jump over with no end over SPB or SPC when it's 0. You always need to program them. To program a reset, we also use Program and Editing, Special Functions, Tilt Machining Plane, and Reset. Then all the spatial angles will be resetted, and we can decide if we want to do a reset of the rotary axis to 0 also. So next step, the positioning behavior. There we have move, turn, or stay. So move, you can see it in the picture. Move says that the rotary axis will do a movement, and while the rotary axis will do the movement, the linear axis will also do a movement, that the distance between the tool and the workpiece stays the same. So that you can use when you are when you did a preposition near to the workpiece, then you can use move, that you do not need to go to a safe position. So you stay close to the workpiece and you can just go on with the next machining. Turn, you can see in the picture, if you program turn, then the rotary axis will be moved around the mechanical turning point of the rotary axis. So there's no movement of the linear axis, only the rotary axis will be moved. So this turn you only should program when you are on a safe position. Otherwise it could happen that you damage your tool, your machine, and your workpiece. So always be careful when you program with turn. Always go to a safe position before. And stay, you see in the picture, stay, there is no movement of the axis, so stay is just a calculation, coordinate calculation. You can use stay, for example, when you only want to do calculation reset, only to reset the tilting to go to the next side. You can also define after the feed rate the sequence plus or sequence minus. So sequence plus or minus says in which direction the first axis of the kinematic should go. For example, you have a table with A and C axis in the table, and you want that the table will always go backside, so in the minus direction. So you program an angle, an spatial angle, A plus 19. Normally the control will move in the positive direction, but if you program sequence minus, then the table will go in the minus direction. But the C-axis needs to do a movement that the workpiece is once again on the same position what you programmed. So you can use sequence minus to tell the control she should use a fixed direction for the tilting. And the second value what you can program is the coordinate rod or table rod. So this is only when you program an SPC angle. So SPA and SPB, 0, nothing inside. When you program only SPC, then the control has two opportunities to do it. The first opportunity is coordinate rod. Coordinate rod says the rotary axis will not do a movement, but the coordinate system will be moved. So your angle on your workpiece. Table rod says the coordinate system will not do a movement, but the rotary axis will be moved, that you have once again the angle on your workpiece. So coordinate rod or table rod is only active when you just program an SPC angle. Because if you program SPA or SPB, then the control needs to move the table or the head to get the correct angle here. The next important thing is the datum shift. The datum shift we need during tilting, just not to calculate so much. If you see the surface here, the datum or the preset is set on this corner, as you see in the picture. When I now tilt at this position, then I need to calculate the distance between the old preset and the surface coordinate of my milling surface. And not to calculate this, it's easier just to move the datum to the beginning of the surface. So just shift the workpiece datum, then rotate the coordinate system. So now you see it good. If I not will do the datum shift, then hopefully it should be aligned. Then this would be our Z0. You see, and I need to calculate this value here to get this correct surface here. So it's better to use the datum shift, otherwise you need to calculate a lot of things. And with an incremental datum shift, you can also move on the tilted surface the datum once again. For example, if you need to do a rotation or a mirroring on the tilted surface. You can program the cycle 7 with absolute coordinates or with incremental coordinates, and you can reset it easily with X, Y, and Z 0. Then you are once again back at the preset. A very important thing for tilting is the program structure. And if you always work with a program structure at the beginning of tilting, then nothing can happen. So everything will work correctly. So program structure, at first you shift the datum to a tilting edge, so to one point of your tilted surface. The next step is tilting. It depends if you say turn or move, that you stay on a safe position or close to the workpiece. Then you make the machining, and after the machining you reset everything. So reset tilting and cancel the datum shift. That's important, because if you do not reset the tilting and you do for the next operation a new datum shift, then the new datum shift will be done in the tilted surface combined with the original preset, and then you come to a complete different point. So always after tilting, reset. If you do not need to reset it always with turn, you can also plane reset stay. So we have here now an example. We want to machine at first the surface, and the second step should be the pocket inside here. And you see, for our example program, the sequence is always the same. At first the tool change, then the datum shift, then tilting on a safe position, then our cycle, our machining, and the next step is reset. So this is now our program. First step, second step, and the simulation for it. And now we want to do this example on the programming station and start here with our programming. Switch. Okay, so on the programming station, at first I go to Program and Editing, and I just make a new program, program1.h. Okay, in millimeter. Okay, so this is our workpiece. You see the blank is X and Y 100 millimeter and that 60 millimeters. So we start with our blank here. Z-axis X0, Y0, Z minus 60, and X100, Y100, and Z0. Okay? So, and now remember the sequence. So at first we make a tool call. I choose the tool face mill diameter 63. Define the spindle speed and the feed rate. Start the spindle. Okay? So, next step, cycle F, coordinate transformation, cycle 7, we do the datum. So the datum shift, we should do to one point on the surface what we know. So when we watch our drawing, we see there are 2 points which I can use for the datum shift. I can use this line here, and I can also use this line here. So for the surface, I can use both, so there's no difference. But if I watch also later at my circular pocket, then it's better to use the upper line to do the datum shift. Okay, so x0, y plus 90, and z0. So the datum shift, okay. Then I can do a preposition x, y, 0 and z 100. Then I am 100 millimeter over my datum shift. And now I can program the plane spatial function. So special function soft key, tilt machining plane, and plane spatial. And now I need to define the spatial angles. And the angle is, you see here, 26.565 in plus direction. So the tool needs to come to me, not from me away. So 26.565. B0, Z0. So I cannot, with no end, I get the information, enter the element, so I cannot overjump with no end here. And then move, because I'm 100 millimeter over the workpiece with a distance 100. That's now the important thing. I always program the distance between the tool and my tilting point. So at the moment I'm standing 100 millimeter over the datum shift, so over my active datum. So this is now the turning point for my tilting. And F maximum without a sequence or a coordinate rod, just end of block. Okay? So next step, cycled F, pocket and stats, and here we have the new cycle 233 of the 640 or the NC kernel controls, machining operation 0, milling strategy 2. Okay, first side length is 100. Second side length, there we now need to be careful, because here we have this is 90, of course, 100 minus 10 is 90, but this length here is longer. So this we can now calculate exactly, or we just say, okay, this value is the 120. So I program 120, and also the coordinate system on the workpiece looking like this. This value is x plus, and this value here up is y plus, because we tilted A plus. So the coordinate system is looking in this way, and this here is the z-axis. It's not so easy to write with the mouse here. So because of this, we need to define the length of this value with minus 120, because plus is the other direction. So minus 120. Starting point is 45, end point is 0, because we did a datum shift on the tilted surface, so we only need to program 0 inside. Okay, then we say fauto, and fmax. And now we need to do a preposition to the starting point. So we are already at x0, y0 at the starting point. So we can directly program M99 and then the machining starts. After the machining, the last point of the sequence is always reset. So we go back again to the position x0, xy, and that and here we say special functions, tilt machining plane, reset and move with distance 100 and maximum feed rate. And also cycle F, go to go to 7, enter X, enter Y, enter Z, 0, end of block. Okay? So this now we can watch at the test run. Okay. Here we can see our movement of the tool and the surface, what we get here. Okay? And now we can use the same structure for the circular pocket. So we can say copy, just insert a comment line and insert again. And now we only need to change the tool. We select now a diameter 16 tool. Change the feed rate. Datum shift stays the same. Save position. Okay. Face milling we need to delete. And here we say now cycle def, pocket and circular pocket. Diameter is, just watch at the drawing, diameter 16 and the deep is 10 millimeters. So diameter 16 and F auto minus 10, plugging deep 10 and 1800 feed rate for plugging. Okay? Then we do the pre-positioning x50, y40 minus, the same like before, and then we can say fmax and M99 comes in the next line. Then pre-position, reset and datum shift, and M30 program finished. So you see structure always the same. At first, tool call, datum shift, tilting on a safe position, machining, and after the machining, reset everything and then go on with the next tilting process. I programmed with Plane Spatial with move. Move you can use when you are close to the workpiece, but move is not always the fastest and the safe way to tilt the axis, because it could happen that you, when you do a movement, that you get in contact with any clamping system on your machine. So it's often the more safe positioning is positioning with turn. For turn, it's important to be on a safe position. Now I want to show you how you can find out and program a safe position. So at first, safe position, when we program in the workpiece coordinate system, then the safe position depends on the preset. So if I have a workpiece which is clamped close to the table or which is clamped far away of the table, then I have different safe positions. Then I need to change the safe position for every program, not to get limit switch error message from the control. So to always go to the same safe position, we can use M91. M91 is always in the machine coordinate system. And this is always the same position in the machine. So this is then, you can see it here, when I program linear Z200, M91. M91 is only active in the sentence which you program. Then the machine will go to this position. So you see in the value here, these values are the values for the reference system. And here you see the workpiece system. It's easily to see it's the actual status here. So now how can I find out the correct position, safe position in my machine? So this is, for example, often the tool change position. So I just go in the manual operation, I go to this safe position, then I press the mode key, and I just change the status display 1 to ref, and then I can read out the actual ref coordinate of the actual position of my spindle. So always think on it. The set position is always the spindle nose, so not working with the length of the tool. So the position, what you see in the set axis here, is always the position from the spindle nose. Also, if there is a tool inside, M91 is not working with the length of the tool. And these values we can use in our program. For example, we can program a label safe, because we always need the safe position for our tilting. Before we tilt, we need to go to a safe position. Before we reset, we need to go to a safe position. So this value is good that you just program it with a sub-program with a label safe. Then if you need to do a changing, because the safe position depends on the machine. So some machines there is Z0 on the top of the machine. On other machines there is Z0 on the surface of the table. Because of this, you need to be careful with the safe position with M91 just to get the correct value for these entries. So now we want to do a changing of our program. So I just copy the program. And I say here, save. So at first, we insert the labels. So label set, save. For example, for the programming station, we can use Z200, M91, and linear X minus 200, Y plus 200. M91 and label 0. You can also find out the safe position. So at the moment I'm standing at the position display mode normal. Mode, display settings, and here I can say I want to have the ref actual and apply. Okay. Sorry. And now you can see I'm at the moment ref actual. Of course the values are now the same, but when we do when we just move away from this position and set a datum, then you can see the differences between our reference system and normal system. So now you see the difference. We have on the left side, we have ref system, so x minus 131, y plus 124, and z plus 118. And on the right side, there we have the normal status display, and here we have x, y, and z 0. So this is just the difference between normal is always the workpiece coordinate system, so the active preset. At the moment it's preset 0, manual 0, and the ref coordinates are always depends on the machine, and these are always the same position in the machine. So the perfect value for working with plane spatial with turn. And this is for the beginning, the safe way to create program with tilting, that you use the safe position with M91. And I always use also label reset, because reset, we always need to do the reset, and inside the reset I at first go to the safe position, call label safe, and then I program the reset, tilt, reset, turn, Fmax, and label 0, okay. And also we can reset here the datum shift. So, and now I can change the program. So, before I start programming, I always program the reset. So if I interrupt the program and tilting is still active, then there would be a problem when you just start here with datum shift. So before I start, I always program call label reset, datum shift, then not the safe position with in the workpiece coordinate system. I want to do call label safe. Then I can program the plane function with turn. Also for reset, I say call label reset, and then the other tool, call label safe, and then plane spatial with turn. The MB is move back. So if you work with turn, you have the value MB. MB says move back. So if you type in 100, then the control moves the tool 100 millimeter in the Z-axis, so in the tool axis, in the active tool axis direction, 100 millimeter, and then with turn you can move the axis. If you program MB maximum, then the control will move the tool as far as it's possible away from the workpiece. But there you need to be careful if you work with head axis, because there often when you program an angle 90 degrees, then MB maximum is not in the highest position. MB maximum is always in the tilted Z axis. So there you need to be careful. So I am not a fan from the MB maximum. I always prefer to program the call label safe or the safe position, and F maximum without a sequence here. And afterwards we program the call label reset. Oh, we forgot the preposition for the surface x0, y0, M99. Then we also see the surface here. So, same program, but now with turn. And if you work with turn, always go to a safe position. And this is, from my opinion, the most safety way to program. Go to a safe position and then start on with the program. And that's what we just learned here. The sequence is always the same. So at first the tool change, next step the datum shift, tilting on a safe position, cycle, so the machining process, and reset tilting. And if you always work with this structure, with this sequence, then you are safe. You program the plane function correctly. So that's all from my side now. So thank you very much for your attention.